All right, so we're back to 6.1. We're doing the second half of 6.1, which is logarithmic functions. And for most people, this is one of their least favorite things in pre-calculus, logs. So I'm going to try to make it as easy as possible on you. If you remember from our last lecture, where we left off was something that looked like this. It might have been -1 or +1, I'm not sure. But anyway, something that looked like this. And I said, how are we going to solve this? Because we can't make the same base, okay? We can't make 77 using powers of 3. Now, it is some power of 3. It's not 3 cubed, because that would be 27, and it's not 3 to the 4th, because that would be 81. But somewhere in between there, like maybe 3 to the 3.81, that's 3.81, or something like that, there's some answer that's going to work. It's going to be some ugly, ugly decimal, but there is some number that you could raise 3 to get 77. And so we got to come up with some way of doing that. And unfortunately, like we were talking last time about the exponentials being natural growth functions and decay functions, the logarithmic function is not a naturally occurring function. So where it came from is from looking at the inverse of the exponential function. So if we know what's going on with the exponential function, which we do, then we should know what's going on with its inverse. So we're going to say that the logarithmic function is defined as the inverse of the exponential. And if we remember that the logs are always related to the exponentials, it can make our life a little bit better. So what we're going to see is written out, it's going to look like this. If we have b to the y equals x. Okay? Now, from what we did in our last lecture, our x and y are in opposite positions because we're looking at the inverse. And remember how we find the inverse by flipping x's and y's? This is going to lead us to our new notation, y equals log base b of x. All right, now, the log, it only exists in that it is the opposite or the inverse of the exponential. So you might see problems where they give you something like this. They ask you to find, what do we got here? Log base 8 of 2. And they ask you to find this. We're not using our calculator. We're going to use what we know right here. This is what we're going to use. Now, a lot of times they ask you to find this, but they don't give you the y equals. So you can always put in the y equals. And now we're going to rewrite the parts in the different places there. So it starts with the b, so it says 8 to the y equals x, in our case, which is 2. So what I like to say is you kind of make a little cloud. You go, start here from the base, 8 to the y equals x. Nice little cloud going on there. Now, from what we were doing last time, can we get 8 and 2 with the same base? So could we write 8 as 2 to the 3 and then include the y? And remember that this is 2 to the first power. So 3y is equal to 1, so y equals 1/3. So this notation right here, log base 8 of 2, is just a really ugly way to write 1/3. All right. All right. So let's do another one of those just so you can get into the habit. We've got, they give us log base 3 of 81. Now again, they don't put that y equals, but it never hurts to put the y equals. It kind of helps you line this up. So we're going to go, start below, go 3 to the y equals 81. 3 to the y equals 81. Okay. Now, 81, we know, because we saw it last time, is 3 to the 4th power. So y equals 4. Okie dokie. So this is an ugly way to write just the number 4. So if anybody ever asks you to write down the number 4, you could be all nerdy and write log base 3 of 81. Okay, well that's wonderful. Okay, so this is the first thing that they're going to ask you to do, is to change form. They're going to give it to you in one form, and they're going to ask you to write it in the other form. Giving it to you one form, asking you to switch back and forth. And that's just helping us get used to the fact that the logs and the exponentials are totally related to each other. Okay? So once we get into that habit, then there are a couple special logs. Okay? So once we start thinking along the lines of log form, okay, with a little bit of practice, there are some that pop up more often than most. And the most common log, well, again, 2 of the most common logs we see is log base 10 of x. Powers of 10 are always nice, okay? 10, 100, 1,000, 10,000, always nice. So we love powers of 10, which means we love logs with base 10. 10s are good when we talk about exponentials and logs. This guy shows up so often, and mathematicians are so lazy that we just start calling it log x. So if ever the little base is missing, there's an implied 10 there. So what that means is if you mean this to be log base 3, you must write the 3 in there, because if the 3 is missing, everybody is going to think you mean base 10. So we have to be very clear. If the base is not 10, make sure it's listed down, because this is the notation for log base 10. So that's one of our special logs. The other one actually gets its own name, and it's the natural log. And this one is a log with base e. So last time we talked about e being that natural growth function, and I told you that there were going to be lots of applications, lots of places where we see this in calculus, business calculus, pretty much any calculus you're going to do, you're going to see e. This guy gets used so often, he gets his own notation. He actually gets his own name. So instead of log, we use ln. And that stands for logarithm natural. So natural log, or logarithm natural, of x. So when you see that notation, there's a little implied base e that's not there, because it gets its own special notation. So you might be asked to let's say that it says write in exponential, and it gives you 4 equals ln x. So we want to write this in exponential, and like we saw over here, we start with the base first. So we're supposed to start here and make this little swoopy thing. Well, there's no base there, but you have to remember that there's actually an e there. So this would look like e to the 4th equals x. Okay. And we'll deal with plugging things into our calculator. I think in the next lecture is when we'll get into the calculator stuff. But right now, we just need to rewrite things. Okay, so first off, again, understanding that the log and the exponential are just cousins. One goes forward, the other one goes backwards. They're totally related. Then the next thing we want to look at are the graphs. And just like with the exponential, how we had 2 graphs, when we deal with logs, we have 2 graphs. So if we're going to graph y equals log base b of x. The first one we're going to do is if b is greater than 1. So just like we had with the exponential, we want our base to be bigger than 1.